Good morning. Hello everyone and welcome back to the channel. Theory earns its badge only in the field. In banking, biases can deny credits. In healthcare, opacity can endanger lives. In government, a single algorithm can shake public trust. Across sectors, the risk looks different, but the remedy is the same: transparency, oversight, and empathy. Let's step inside real world stories where governance turned potential disasters into learning victories. In today's episode, we are going to go deep into one of the most important topics in responsible AI. Understanding how AI risk manifest across the entire ecosystems and how we can build the guardrails that keep them in check. We are in part 6 of this series. Today's topic is on sector specific case studies. We look at risk manifestation and guardrails that are available. The agenda is as shown. So, whether you are a technology leader, compliance professional, or student of AI governance, this episode will help you see the complete picture. We'll start with technical and model risk level. Of course, before that, we look at few of the case studies in BFSI, healthcare, public sector. We look at comparative insight across sector. We look at cross sector lessons. We look at metrics for these cross sector benchmarking. Then we move on to the topic on guardrails and how it addresses the AI risk manifestation. So we'll start with technical and model level risk, where issues like data poisoning, model drift, and explainability deficits can silently erode the trust. Then we'll move into ethical, social, and human level risk, exploring how AI can amplify biases, manipulate behaviors, or undermine consent if not managed responsibly. Next, we'll unpack operational and organizational risk, whether governance, accountability, and skill gaps can become the weakest link even in the strongest AI program. From there, we'll expand into systemic, strategic, and reputational risk, the high impact board level issues, where misaligned governance or lack of transparency can lead to public backlash or compliance exposure. And finally, we look ahead to the meta risk of the future. Emerging challenges like prompt injection, synthetic data misuse, deepfake, hallucination, and sustainability impact. But more importantly, for every category of risk, we'll explore the guardrails that protect us. Could be data fairness control, explainability framework, privacy by design, monitoring systems, human in the loop oversight, bias audit, and transparency tools like model cards and governance dashboards. Because AI risk management isn't about slowing innovation, it's about steering it safely. So stay tuned as we map the full spectrum from model level precision to boardroom accountability and see how layered guardrails transform uncertainty into assurance and complexity into trust. This is your host, Savit Vittal Salian. Let's start the journey. Namaskar. Case study 1. This is from the BFSI sector. Let's look at the context. A large retail bank deployed a gradient boosted credit scoring model, trained for 5 years of legacy lending data. After 6 months, approval disparities across gender group rose, triggering supervisory scrutiny under fair lending obligations and EU AI Act's high risk classification. So, a credit rating model was built. The model used the data of 5 years, of past 5 years or 5 years of data, and it was noticed there was disparity. What was observed is, from a risk perspective, there were data biases, model drift, and there was deficit of explainability. Under data bias category, it was identified there are historical underrepresentation of female entrepreneurs. So, which means female entrepreneurs were less privileged in this rating because the base data was not adequate or balanced enough. So, they were put at disadvantage because of the legacy data that was used for. The second, it was identified that the data which was used, the 5 years data, were from the pandemic era. So the correlations as such had an issue. So prior correlations were not relevant. So there was a drift in the model. And the major challenge, the third one, was there was no auditable rationale for automated decline. Why there was decline of approvals for female entrepreneurs? What was the reason? That was not auditable. The answers couldn't be found. So let's break it. First, we look at the data bias aspect. The risk manifestation was data bias. Cause was historically underrepresentation of female entrepreneurs. So what's the guardrail? The first guardrail is data fairness that was used. We'll discuss data fairness as we move forward. In here, the tools that could be used or was used, even you can look at your own case studies. You have options such as the IBM AI Fairness 360 and of course resampling. Now doing this reduce the gap which was earlier noticed. For this case we can say it was 12%, it was reduced to 3%. So resampling and using the right tool helped from mitigating the data bias risk. The second risk was model drift. In this case, the control is monitoring. You can use tools such as Evidently AI or Power BI dashboards. And the action is checking the monthly drifts, enabling fairness KPIs, and auto alerting to the CRO when there are major shift in the KPIs. The third risk manifested itself as an explainability deficit. There was no auditable rationale for why there was decline. Let's see our explainability domain. To address this, you have tools such as SHAP and Lime integrated into your flow. This provides you with a feature importance visualization which could be appended to your loan files, which is basically to show how the loan processing flowed from start to end till the time it was declined, as what part or what caused the decline to happen. The next one, again from the explanatory deficit perspective, is you have governance domain. That's the control. You can use ISO 42001 AIMS pilot, and you can have your approval gates. Do note this discussion on approval gates was put up in video number 3 for this series. You can have a look into it, and the 4i validation. So the risk manifestation was 3, which is data bias, there is model drift, and there was an explainability deficit. From a guardrail perspective, you have to use, or you can use, data fairness, explainability, governance, and monitoring. The outcome of these guardrails is you restored regulatory confidence, validated under the SR 11.7 and AI Act of Article 9. The next outcome is having an embedded bias testing as a code in CI/CD and shortening the validation cycle by 60%. The lesson learned in this is fairness is a moving target. Treat bias remediation as a continuous service, not a one-off audit. Second case study is from healthcare sector. This is about the diagnostic AI explainability and patient safety in radiology department. A hospital consortium introduced a deep learning model to detect pulmonary nodules. Early pilot showed 94% accuracy but zero clinical adoption. Result, radiologists distrusted the black box. A later misclassification incident elevated the issue to patient safety board. There was a trigger. The risk manifested itself under opacity, operational dependency, and compliance exposure. Why opacity? Opacity. Clinicals lacked the causal reasoning for AI output. Operational deficiency, there were alert fatigues due to false positive, a major challenge in this space. Next was compliance exposure, that is breach of explainability requirement of EU MDR and HIPAA transparency clause. Basically, the regulators need to have a very clear explanation on what happened. That was missing in this. So the guardrails that was applied for opacity, operational dependency, and compliance exposures were 4. First was explainability. In this, the tools were GradCam and SHAP overlay, which provided the visual heat map on X-ray enabling human validation. Second control was human in the loop. The technique is, a tool was confidence-based routing, wherein whenever the case had less than 80% confidence, it was auto-sent to the senior radiologist. So you had a human in the loop to review it. The third was privacy domain, wherein we used tools like federated learning plus DP, which enabled multi-hospital training without raw data exchange. So you would have used a wider set for testing. The fourth was governance. You had AI safety committees or model card registry, and each of these were documented and audited. The outcome of these, the post-deployment confidence increased. So, and there are no further misclassification of incidents in the 12 months. The lesson learned here is explainability isn't optional healthcare. It's a safety control. So if you think through, in this case, your risk was opacity, operational dependency, and compliance exposure. Guardrails were explainability, human in the loop, privacy, governance. Yes, we'll go through each of these in detail as to what does each mean as we move forward. The third case study is from public sector. This is wherein a national social welfare agency rolled out an AI systems to flag fraudulent benefit claims. Within months, error-laden denial triggered protest and inquiries. The risk manifestation was algorithmic opacity and data bias against rural applicants. There was governance failure as there was no public model documentation, and there was a reputational collapse. AI injustice headline eroded the trust. In this, the guardrails and tools applied were, first of all, from a control domain, we had transparency issue. So in that case, to address it, we use public model card and policy summaries, wherein citizens could view the logic, the data source, and the appeal rights for their individual cases. The next was bias audit. There was independent academic reviews. This helped to reduce the bias gap, and the findings were published openly for everyone to see. It helped with the transparency. Next was governance issue. For that, the organization applied NIST RMF or ISO 42001, wherein they mapped the harm, and periodic audits were also enabled. On the incident responses aspect, there are hotlines created, workflows were redressed, and with a target of resolving certain percentage of appeals resolved within less than 30 days. The outcome of this is the public trust index recovered, the legacy transparent portal become a national template. The lesson learned in public service, explainability is equal to democracy. Let's now go deeper. So in BFSI, what matters is, from a regulatory baseline perspective, you have the AI Act, you have SR11 and DPDP. The primary risk type, if in BFSI sector, is biases and drift. The key guardrails is bias testing, its pipeline. The dominant metrics is fairness gap. The governance model is the 3 line of defense and AI risk committees. The outcome, you have regulatory assurance and a trust on your portfolio. If you are from a BFSI sector, look at these and compare it with your own systems. Do you agree or are you in line with this? In healthcare, the regulatory baseline is EU MDR, HIPAA or AI Act. In healthcare, the primary risk type is explainability and safety. And the guardrail is human in the loop routing. And the dominant metrics would be diagnostics confidence percentage. The governance model recommended for these is having an ethics board, having a clinical safety officer in place. The outcome is clinical adoption and zero harm. Do note this is specifically for healthcare. For public sector, the regulatory baseline is AI Act, data protection and administrative law. In this case, the primary risk type is fairness and transparency. Do note what I am listing here in this slide or the earlier two ones was the primary risk type. The secondary and others would follow, but primarily for public sector it's fairness and transparency. In this case, the key guardrail would be public model cards. The dominant metric would be appeal resolution time, by when you will solve the issues. The governance model is independent audits and citizens oversight. The outcome, you restore public legitimacy. So the lesson learned here is Bias, explainability, and transparency are universal across the stream. You should be able to explain if there are any biases, why, what happened, and transparency. Why? Because context changes the emphasis, not the necessity. The second lesson learned is regulatory alignment precedes innovation. You can have an excellent and awesome tool, but it need to be aligned to your local regulation or regulators who define your business or the way you do your business. Early mapping to frameworks saves crisis data. Third lesson, human oversight is non-negotiable. Each domain needs domain experts' vetoes. The fourth learning is continuous monitoring outperforms post-incident forensic. You need to embed alerts, not apologies. The fifth learning is public trust is the real KPI. Whether clients, patients, or citizens, perception is a risk asset. I remember one of my bosses saying perception is reality. It's very much true in this. Key takeaway, across industries, one constant emerges. AI safety lives in loop between data and decision, model and human, algorithms and accountability. The AI safety lives in a loop. The sector that thrives are those that treat governance as an infrastructure, not paperwork. Let's look at some metrics, suggested metrics. For BFSI, the bias gap can be set at lower than 5%, but the coverage has to be 100% for critical models. And human in the loop intervention for high impact at least should be higher than 1, or higher the better for every 100 decisions. You can take a call what works for you based on your appetite. And incident MTTR should be lower. Now you have to decide the number. In this case, I have set up 14 days. That's 2 weeks for end to end to find the root causes, action, if possible, closures. For healthcare, bias gap should be lower than 5%. It can be lower based on your risk appetite. Explainability should be 100%. In healthcare, should not be any negotiation there. All 80% confidence cases should have a human in loop. Less than 80%, you need to have a human in the loop. And because it is healthcare, your MTTR can't be more than 7 days. It should be less than that. But again, this is an individual organization's call based on their risk appetite. The next is public sector. Bias cap should be less than 10%. Explainability coverage should be 95% and above for most of the case. All appeals should be eligible for a human review. Because it is public sector, the duration or MTTR could be higher, but definitely keeping it less than 30 days sounds logical. The industry baseline is generally based on industry benchmark into 0.5. That's how you look at the numbers. Explainability should always be in and around greater than 95%. Your human in the loop should have a structured override policies. It's not silver bullet, one for all. Your policy should define at what point human intervention would trigger in. In conclusion, sectoral differences matter, yet the risk DNA is shared across. BFSI proves precision and accountability can coexist. Healthcare shows explainability is safety. Public sector reminds us transparency is equal to legitimacy. Together, they demonstrate that AI risk management, when tooled and governed correctly, is not a brake, it is a steering system of digital trust. So, how guardrail address AI risk manifestation? Well, every AI system carries potential risks, data biases, model drift, opacity, safety deficits, compliance gaps, and even reputational collapses. But mature organizations don't react to risks. They architect guardrails that make the system resilient by design. Think of guardrail as the control surface of AI governance, each one protecting against a class of risk manifestation. Let's now go deeper into the risk manifestation and its guardrails. The first is data biases. In this, the risk manifestation is when training data reflects social or sampling biases. AI replicates or amplifies those inequities. Here, the guardrail is having data fairness. The guardrail, when you look at it, has few components. First, the data fairness programs ensures a balanced data sets, documented lineage, and continuous bias testing. You can use AIF 360 or FairLearn in this case. Bias audits qualify metrics like statistical parity or disparate impact ratios. This guardrail also has remediation rules which triggers retraining when fairness metrics fall below a threshold. Now do note, the organization need to define the threshold, and the thresholds are defined by the appetite, the risk appetite of the organization. So it goes back to the principles. The impact of this is the fairness guardrails transforms ethics into a measurable KPIs, protecting the institution from discrimination claims or regulatory actions. So this shows the risk manifestation when it is data bias, how the guardrail of data fairness helps it. The next risk manifestation is model drift. Model degrade as real world data changes, leading to inaccurate, outdated, or unsafe prediction. That's your model drift. For this, the guardrails recommended is monitoring and retraining. Continuous monitoring system tracks the input and the output and able to identify the output drift in comparison to the input. Automated retraining pipeline refreshes the model periodically or on drift triggers. So the question that you should ask is, do you have continuous monitoring system in place which checks for the input and the output against the threshold, against the boundaries or the benchmark that you have set for? If so, do you have an automated retraining pipeline in place or a model in place where you do a continuous retraining? You can set up the intervals. Or do you have a mechanism today in place which could trigger a retraining once a particular threshold is breached? That's model of monitoring and retraining required as part of the guardrail. The next is alert escalation to data science and governance teams, ensuring timely remediation. So whenever there is a drift, you would need your data science team and the governance team to jump in, to look at the cause and effect, to see what is required to fix it. That's a guardrail response. If you do this, these guardrail ensures reliability over time, converting the AI decay into an AI maintenance, much like preventing servicing for an engine, preventive servicing for an engine. So do you have that in place today? If not, what is required? That's the question we should look at asking in our meetings with data scientists and your governance team. One of the metrics that I recommend highly to the management when you're looking at from an AI model perspective is this aspect of checking out what was the drift for each model. Was there a drift? Do you have that metrics in place? If the answer is no, time to trigger that conversation and set that. You can always fine tune it. But that's an important guardrail metrics that is required. This will address your model drift issues. The next risk manifestation is explainability deficit or algorithmic opacity. This is where the black box decisions erode stakeholders' trust and make regulatory defense impossible. A real challenge in many of the AI implementation. It's a black box or a semi-black box. In this case, the guardrail is explainability and transparency. Explainability engine like Shape and Lime provides interpretable output. Basically, the idea here is to know why things happened the way it did. Transparency dashboard shows rationale, features, and the decision pathways, how the whole thing manifested itself. The next is public model card summarizes intended use, its limitation, and the performance metrics. The question that you should ask to the AI leads, the AI heads, the owner of the AI model or the tool should be, is there explainability for all that is there? Is there transparency? Is there a dashboard which shows features, the decisions, how it workflow? Is there a documentation which provides the intended use, its limitation, and its metrics? Once done, it turns opacity into transparency, if done right, enabling both internal accountability and external explainability during audits or media scrutiny. The next risk manifestation is safety deficit or operational dependency. This fully automated systems can make unsafe or unreviewed decisions, especially in critical sector like finance, healthcare, or transport. Here, the guardrail is human in the loop and fail-safe design. Human in the loop checkpoints for high risk or low confidence output. The safe fallback mechanism revert control back to the human operator when an anomaly is detected. Decision override logs ensures traceability and training feedback loops. For the management to address this risk, the question that we should be asking is, what are the checkpoints for human, for all the systems? What's the safety mechanism to fall back? How would anyone know when things are not going in the right direction or heading towards a disaster? Can we stop? Can we revert? Is that mechanism currently at play? At what point that we can't return back? Is there a point? Or where are the checkpoints from where we can go back, where we can stop the damage? More importantly, how well are the logs triggered? What gets recorded? So, in case of a disaster or a failure or a potential failure, by looking at the log, we can know what worked, what did not. Is that mechanism currently at play? Is that enabled? Is it available? If you address this, the impact, it protects the brand and customers by embedding human judgments where algorithms have blind spots. First of all, does the management know what are the blind spots? This is where you have to declare your blind spot. Test first to know you have a blind spot. Testing blind spot is part of pre-implementation, a critical compliance expectation under the EU AI Act. The next risk manifestation is from opacity and governance failure. This is about lack of ownership or having a fragmented oversight and policy gaps leading to ungoverned AI decisions. The guardrail to address this is governance and accountability structure, having a governance and accountability structure. AI governance committee define risk appetite, policies, and escalation path. Here we pause and ask as a management to the technical team and the risk team and the governance team, do you have an AI governance committee? Have you defined the risk appetite? What is your policy and what are your escalation paths? The model registry and documentation enforce life cycle traceability. Do you have one? You need to have periodic governance review, at least quarterly, to validate adherence to the framework. The question that you should ask is, do you have a review? And how do you ensure you are adhering to the framework? Here I mentioned NIST, I mentioned ISO 42001, but you might have your own, the one which matters to your industry, your geography, or your business. So how do you prove that you are adhering to the framework? What is the mechanism? Is there a validation? Is there someone saying that yes, we are aligned? But who is verifying it? It need not be done every time. At least when you launch it, it should be clear, and then maybe twice a year, thrice a year, depending on the investor time and energy. If it is manual, big challenge, recommended is automated. If you have these guardrails, you create a chain of custody for your decisions, ensuring every model has an owner, every owner has an accountability, and every decision has a record. That's the impact that you cause having these guardrails in place. The next risk is from compliance exposure. AI may violate the data protection, may violate consent or transparency laws like GDPR, DPDP Act, or EU AI Act. The guardrail for this is privacy and regulatory mapping. You need to have privacy by design control, which is basically data minimization, anonymization, encryption. So, as a management, we need to ask this question, is our privacy by design control in place? What is that we have defined? What is data minimization for your model? What is anonymization methods that you have used? How is it tested? What's the encryption that you are using? How is it tested? What is the frequency of these testings? Is there a consent traceability log linking each data set to lawful basis? When someone is consent, is there a record? If there is a change, has there been a reconsent? Is there a proof that a consent was taken? How do you trace when consent was required and one was taken? Was it taken? Or how many were of the grid. How do you know that you have not missed a consent? What is the definition of a consent for your model? What granularity of consent that you have taken? The next is regulatory mapping tools that track which model falls under which compliance obligations. Do you have that mechanism in place? Are you able to map your tools against the regulatory requirement for your business, for your industry? Are you clear about it? Is there a clear visibility on that mapping? Do note, this is important before the launch, but also when there are changes to your tool, features, functionalities, or the complete structure has changed. You might keep the name of the tool same, but the whole functionality has changed by 20%, 60%, 80% or so. The whole compliance mapping also would change. It would require a reconsent. Is that in place? So this is a guard rail response for compliance exposures. This shifts compliance from reactive checklist to embedded control design, ensuring the organization stays audit ready always. The next risk is from reputational collapse or public trust risk. This is AI failures or unethical behaviors can damage your brand credibility overnight. To address this, the guardrail here is transparency and public communication. Here, public model card and responsible AI reports disclose performance and ethics commitment. Do you have a public model card? Do you have a responsible AI report which discloses this? The next is bias and safety audits published voluntarily to show accountability. What is the mechanism of audits for your models? Do you have one? Is that audit taking care of the biases and the safety aspect? Are they published? Where? Are they published to the right stakeholders? Stakeholders who are impacted by your model. The next is incident communication protocol, ensuring rapid and transparent response. This could be aligned to your current incident management process, but factoring in the AI aspect. Once done, this turns transparency into a competitive advantage, positioning the organization as a trustworthy by default. That's the impact to the management. The next is from fairness and transparency breakdown. Unequal treatment or hidden logic leads to social and legal backlashes. That's how the risk manifests. Here the guardrail are having a bias audit and having a governance review. Bias audits are required before deployment and then periodically. So before is so much critical. Need to have cross-functional reviews including ethics, legal and risk teams. The question to be asked is, do you have that audit before deployment? Are those audit results available? Are the audit report reviewed against your policy, against your metrics, against the guidelines, against your regulatory requirements? Have they passed all of those, and then, only then is when the deployment should be triggered? And then, do you have a review across the teams? Do you have a fairness certificate for high impact AI systems? Have you defined what a fairness certification means? How it looks like? When you say fair, fair to whom? Is that definition cleared? Fairness to the stakeholders, to your regulators, to the business. Are these defined? What those certification mean? So when you release a certificate, does your stakeholder understand what that really means? Having this demonstrate active stewardship to regulators, board, and the public, turning fairness into a documented control and not a claim. The next is incident or failure event risk. Here, the risk manifests itself as unexpected behavior, harm, or regulatory breach from an AI systems. To address this, the guardrails here are incident response playbooks. AI specific incident response plans integrated with enterprise crisis management is a need here. That's a guardrail. Do you have an incident response plan which is integrated in your crisis management? Does your root cause analysis protocol for model failures, biases, or security compromise, do you have that RCA playbook in place? Most of the playbooks are not been designed for AI models. This guardrail requires it to be to address the risk. You need to have a corrective action tracking within the governance dashboard. If these are in place, this ensures resilience, transforming incidents into learning loops and protecting long-term trust. So these are the guardrails for the risk related to incident and failure events. I hope this helped in some way. The next is technical and model level risk. But before we go there, let's try to summarize what we learned. Guardrails are not just technical controls, they are organizational reflexes. They translate governance framework into real world accountability. Bias audits protect ethics. Monitoring protects performance. Explainability protects credibility. Privacy protects compliance. Human in the loop protects safety. Transparency protects reputation. Together, they create a system where risk is not eliminated but contained, measured, and managed, turning responsible AI from aspiration into architecture. The next category is data poisoning or contamination, wherein malicious or accidental insertion of corrupted data during training or retraining could occur. They manifest in practice, they compromise the model behavior, leading to biases or manipulated outputs. The guardrail for this is having a trusted data pipeline, having data validation in place, enabling access controls, and having anomaly detection in place. These are the guardrails. The next category is adversarial attack, wherein the inputs are intentionally crafted to fool the model. Example, slight image preterption. This causes misclassification or exploitation of the AI design logic. This is part of the adversarial attack. To address this, the guardrails are having adversarial robustness testing, ensuring you have a mechanism for hardening your model, and yes, having red teaming in place. The next is model extraction or theft, wherein the attacker replicates a model by probing its outputs. This can cause IP loss, security breach, and regulatory exposure. The guardrail for these type of risk is having an API rate limiting, watermarking, encrypting your queries, and model obfuscation. These are your guardrails for model extraction and theft. Next is model inversion and data leakage, wherein sensitive training data are reconstructed from model outputs. It violates the privacy and compliance norms. The guardrail for this are having differential privacy, having a federated learning in place, and enabling access control. Do note, model inversion and model theft, these are two different risk categories. The next is overfitting or underfitting, wherein the model performs well on training data but fails on new data. This reduces the reliability and the business value. To address this, the guardrails are having cross validation, regularization, and retraining on diverse data sets. So these are the guardrails against overfitting and underfitting risk. The next is model drift or data or concept drift, wherein input or the target distribution changes over time. This is where model accuracy and the fairness would degrade. It's not sudden, it is subtle, silently over a period of time. To address this, there are three guardrails which can be used. One is having drift monitoring in place, triggering retraining once it reaches a particular threshold or reduces a particular level of accuracy, and having a mechanism where you periodically validate the input and the output to check whether the output has a deviation beyond the accepted threshold. The next is explainability deficit or a black box behavior, wherein the decision logics are opaque or unintelligible. This reduces the accountability and the auditability of the model. To address this, we have guardrails such as SHAP, LIME, we have interpretable models and model documentation. These four guardrails helps to address the risk of explainability deficit or black box behavior. The next is lack of robustness or fragility, wherein the model fails outside its training domain, making it inconsistent or unsafe. To address this, guardrails such as stress testing, scenario simulation, boundary condition validation are recommended. This would help you address the risk associated with robustness and fragility of the model. The next is misaligned objective function, an underrated risk but important, wherein the model optimizes metrics that don't align with the ethical or your organization business goals. It's a harmful trade-off between profit and fairness. The guardrail here are having a human review of the model's objective and having a multi-objective optimization in place. You need to involve multiple units: legal, risk team, governance team, ethical board, senior management for this space. You need to define your principles, the way you conduct your business. The next one is dependency on proprietary or unverifiable models. The black box external models without visibility into inner working is this form of a risk, wherein it limits the assurance and governance. If you're bringing in a model from outside and you don't know how it works, you might know the output, but you don't know how it comes to the conclusion, you have a challenge here. The guardrails here are having a vendor due diligence, having a contractual guardrail, and a clear explainability by design. Everything is documented, is clear, and can be interpreted. But then this is something that you do before you onboard it, before you even bring in an external model in. Next is ethical, social, human level risk. In this category, you have the first risk of cognitive bias amplification, wherein AI learns and scales human bias embedded in the data. This perpetuates discrimination or inequality. This could. The guardrail that is expected here is having a bias audit, having diverse data set during your tests when you conduct your base, and having a clear fairness metrics. These guardrails help you address the risk arising out of the cognitive bias. The next is manipulative or deceptive output risk. Here, AI pursues or nudges users unethically. Could be in form of ads or political messaging. This undermines autonomy. It hits your transparency or consent space. The guardrail recommended here is having a consent moderation, having a disclosure, a transparency disclosure, and explainable interaction design. These guardrails should help you work around the risk category of manipulation or having a deceptive output. The next category is human over-reliance or automation bias, wherein users trust the AI decisions blindly. This reduces the vigilance and the related accountability. The guardrail here is having a human in the loop checkpoint, enabling training, and having a confidence calibration done. This needs to be done regularly. The next category of risk is dehumanization or displacement risk, wherein AI replaces human empathy or judgment in sensitive areas. Could be healthcare, especially healthcare and law. This manifests into ethical erosion or user alienation. The guardrail here is having policy limits on the scope of the AI and having a hybrid decision model in place. So these two critical guardrails would help you address the dehumanization or displacement risk. The next risk in this category is synthetic consent misuse, wherein it generated image or videos or text are used maliciously. This could hit your reputation, spread misinformation, and could potentially cause fraud. To address this risk, the guardrail recommended is having an output watermarking, a consent authenticity infrastructure. These two guardrails help address the synthetic content misuse. The next category is informed consent erosion, wherein AI collects or infers personal data without the user's awareness. It manifests into privacy and legal violations. The guardrail for this risk are two: having an explicit consent management in place and privacy by design controls. These two should help address this risk of informed consent erosion to a large extent. The next risk is digital inequality or accessibility bias, wherein AI serves or performs better for certain user group. That's inequality, that's bias. Providing unequal outcome and service quality for groups. To address this, the two guardrails recommended are having an inclusive data set design and having an accessibility audit. The next is psychological harm or trust erosion risk, wherein the user feel surveilled, manipulated, or judged by an AI. This decreases public acceptance of your service or AI service or the model. The guardrails that is expected here, which can help you address this risk, is transparency and ethical design review boards. Operational and organizational risk. The first risk is model lifecycle mismanagement. This is where you have poor version controls, untracked updates, or lack of rollback plans. This could cause operational chaos and audit failures. The two guardrails that is recommended here is having an immutable model registry and having CI/CD with approval gates. The next category of risk is lack of incident response preparedness, wherein you have no process for AI system failures or ethical breaches. This delays mitigation, causing reputational loss. The guardrail for this is having an AI specific incident response playbook. Do note it's a playbook that you have to define. You might have this central incident management team, but it needs to run the AI specific incident using the AI playbook. So have you defined that playbook? Do you have it in place? If not, it's time to do it. The next risk is vendor and third parties, wherein we have dependencies on external AI APIs or data sets without oversight. This could cause serious compliance and security exposures. There are three guardrails recommended: having a vendor audit, having contractual guardrails in place, and having an enforcement of SLAs defined clearly, articulated well, so that it covers you well. The next risk is data supply chain vulnerability. wherein you are using unverified data source in the model pipelines. This could compromise your data quality or security. The two guardrails that is recommended is having a trusted data pipelines and provenance tagging. The next risk is from tool chain security weakness, wherein MLOps tools are misconfigured or are exposed. Could cause adversarial manipulation or IP leaks. There are three controls recommended for this: access control, patching, and having a continuous vulnerability scanning. Do note here as we speak, you would notice there are certain guardrails which are already in play for your general IT support, for your cyber security or security metrics. So there would be many guardrails which you are already using. What you have to do is you have to align that, maybe tune a little bit to get it aligned for AI use. The next risk is workflow skill deficit, wherein the team lacks the expertise in AI governance, ethics, or assurance. A poor risk awareness or slow response is the outcome of this. The guardrail here is having training and certification programs and having a governance onboarding process. The next one is process non-alignment risk, wherein AI development is disconnected from the enterprise GRC process. There are gaps in control mapping, there are audit issues, and so on. To address this risk, you need to have an AI GRC integration in place and a unified risk register. Finally, in this category, we have monitoring blind spot risk or risk of blind spot. How do you monitor it? Wherein lack of continuous tracking for fairness, drift, or biases could be your blind spot, which could silently degrade or could cause harm which is not noticed initially. The guardrail here is to have an integrated AI observability dashboards. The next category is systemic, strategic, and reputational risk. The first is regulatory non-compliance and exposure from legal aspect. This is about violations of GDPR or DPDP Act or EU AI Act requirements, which could result in fines, sanctions, or operational bans. Here, the guardrails are having legal reviews in place, possibly having automations on your policies, and conformity assessment as part of your process. The next risk is governance collapse, wherein you have roles are not clear, oversight is inconsistent, and accountabilities are missing, which could lead to loss of controls, causing systemic risk. To address this, the guardrails recommended are having an AI risk committee, having a clear escalation procedure which are tested, and having a board reporting mechanism in place. The next risk category is from reputational collapse, wherein you have public backlash over unfair or unsafe AI behaviors, which could lead to loss of trust, revenue, and credibility. To address this, there are guardrails such as having transparency report being published and a protocol for public communication set and tested. The next risk is misalignment with human values, wherein AI pursues goals that would conflict with the organizational ethics or social norms, causing ethical crisis and stakeholder pushbacks. The guardrail for this is having an ethical AI framework defined clearly, articulated, documented, and having a human in command principles in place. The next risk in this category is cross system interconnectivity risk, wherein AI interacts with other systems in unpredictable ways, could have a cascading or a systemic failures. The guardrail for these managing these risks are having clear network isolations, having a testing in place for resiliency, and having systemic risk modeling defined and set up. Of course, tested also. The next risk in this category is concentration risk, wherein there is over reliance on one model or one vendor or one data source, causing single point of failure. The guardrail for this is having redundancy in place, having vendor diversification, and a fallback system in place. These are three guardrails which could help address the risk coming out of concentration risk. The next risk is model reuse or shadow AI, wherein unauthorized or outdated AI models are reused by the teams, which could cause uncontrolled risk proliferations. If it is an AI model which is outdated, the risk of that would automatically get manifested into a newer model if the new models are using those. So it is uncontrolled. To address this, you need to ensure two important guardrails. First is having a central AI inventory and having an access gatekeeping in place. The next risk in this category is cultural resistance or ethics fatigue, where over-regulation or unclear messaging could lead to disengagement, which could cause loss of governance adoption. To address this, there are two important guardrails. One is having a simplified policy in place and constant leadership reinforcement. The next category is meta risk or next generation or emerging risk. The first one is generative AI hallucination risk, wherein AI invents facts or causes misleading or creates misleading information. This could lead to misinformation and liabilities for your organization. The guardrails for this are first having prompt firewalls, a mechanism for fact verification of APIs, and human moderation set in the process itself. The next risk is synthetic data misrepresentation, wherein synthetic data fails to preserve the statistical integrity, which could lead to misleading model performance metrics. The guardrail that can be set is having a synthetic data validation framework in place. The next risk in this category is prompt injections and jailbreaks, wherein malicious instruction could bypass the intended rules. wherein model exploitation or data leakage could be triggered. The guardrail in this space is having a prompt firewalls, sandboxing, and having a red teaming of your LLM. The next category of risk is AI model collusion or emergent behavior, wherein multiple AIs interact in unanticipated ways, causing systemic or an ethical drift. The guardrails for this could be having an AI inter-system monitoring in place and enabling simulation testing before deployment and post deployment at regular interval. The next is quantum or compute dependency risk, wherein AI models are relying on high computational resource, creating inequality or fragility, causing systemic inefficiency or causing environmental risk. The guardrail for this is having an energy aware AI optimization in place and having a compute governance setup. The next risk comes from environmental and sustainability impact perspective, wherein excessive carbon footprint is created from model training, triggering an ESG non-compliance. The guardrail for this is having a green AI initiatives or tracking your efficiency. The last of the risk in this category comes from synthetic identity risk, wherein AI generated persona is used for fraud or misinformation, causing cyber security and reputational exposure to the organization. The guardrail for managing this risk is having an identity verification being set up and an authenticity markers enabled. So in summary, the risk in technical domain could manifest as data poisoning, model drift, or explainability deficit. To address this, you can or rather have an option to implement fairness, robustness, monitoring, and validation guardrails. With ethical and social risks, the risk would manifest itself as from manipulation perspective, bias, consent erosion, or deepfakes. The guardrails here are transparency, having an human oversight, and having audits on bias. From operational risk perspective, the risk could manifest itself as governance failures, incident mishandling, or skill deficit. The guardrails here are having a governance structure in place, an incident response in place, and training. From strategic and systemic risk perspective, the risk could manifest itself as compliance exposure. It could manifest itself as from reputational collapse or value misalignment. The guardrails would be policy governance, transparency reporting, and having an ethical design in place. From an emerging risk perspective, the risk could manifest itself as through hallucination or prompt injection or sustainability impact. The guardrails here would be having prompt firewalls or watermarking or an ESG aware AI. The final takeaway: AI risk is multidimensional. Technical failures may start small but cascade into ethical, operational, and reputational crisis. The key to resilience is layered guardrails or having it in place, like fairness for biases, explainability for opacity, monitoring for drift, privacy guardrails for compliance risk, governance guardrails for accountability risk, transparency guardrails for trust. In mature organizations, every risk manifestation has a corresponding control family, forming a complete AI assurance architecture that prevents single point failure and systemic fragility. Across every sector, the lesson repeats. Transparency earns trust. Whether it's a loan model, a radiology scan, or a welfare algorithm, fairness and explainability are the new currency of credibility. AI risk management works when leadership treat ethics as infrastructure. As we move forward, let's explore the frontier where emerging technologies like generative AI and autonomous agent reshape the risk horizon. With this, we have come to the end of this part of the video. We have few more videos for this series. I would like to personally thank you for the time if you have reached up to this point. Much appreciated. Do like if you think this has brought value to your table. Do share with your colleagues who you think can benefit from this. The idea is to share and grow together. This is your host, Savit Vittal Salian. See you in the next video of this series. Namaskar.